Good afternoon, class. Today we're going to be learning exponential growth function 6.3 and 6.4, part 1.
So guys, this week we don't have class on Wednesday.
Why? What?
Because of MCAS.
I used to go to shop.
Yeah. So there's no we have no class on Wednesday. On Thursday, we only have a single period.
You joke. I just this one.
Huh?
Is this the single period?
No, I'm saying usually it's period 7, 8. I think we only have period 8, right? And so I don't know.
Yeah, we only have 8.
So basically, class is getting cut in half on Thursday. We will still, guys, have a test on Friday, and Friday will be your last test of the year. Your last, and then obviously we'll have the final at the end. We'll talk about that at the end of the notes. Right?
I'm ready for school to be over.
So guys, today we're going to talk about exponential growth. So that's going to deal a little bit with fractions, and you're going to know how fractions work. All right? So, on your notes, guys, I want to ask what an exponential function is. Well, just like we did like a linear, someone tell me, what's a linear function? Which equation is going to give us a straight line that we talked about this year?
A linear.
Yeah, but what we're doing for exponential is y equals a times a b to the x. Exactly. That's a linear function. Y equals mx plus b. That'll give us a straight line. All right? An exponential is going to be a little bit different. But just like, remember when we did y equals mx plus b, slope intercept form? Remember m meant slope, b meant y intercept? When we're doing this, the exponential function, y equals a b to the x, all right? There'll be certain things in that formula that mean things too. All right? So an exponential function is a function of the form, that's the form we're talking about. So again, it's like that basic, this is like slope intercept for a linear function. This is the basic function for exponentials. All right?
Why do you have a b instead of m? Why?
There's no slope in this.
So.
Because remember, for a linear function, we have the slope, right? But it's increasing by the same value. You're going up by that same value every time. Something a little bit different is going to happen for an exponential. And we'll talk about that in a second. All right? Biggest thing for this formula is the a that we give you, whatever is in the a spot, it cannot equal 0. All right? B has to be greater than 0, and it cannot be 1. So every number goes in that B spot, it's going to be greater than 0, but it can't be 1, but it cannot equal 1. All right? When we have you guys, say if we were going to have you guys write an exponential function, when we have you do that, y will just stay as y, just like slope intercept form, right? When we had you guys write something in slope intercept form, y stayed as y, right? X stayed as x. You needed the x to tell you where the slope was, right?
I don't understand what that writing means.
What?
Where a weird mark 0.
So we're B. This means can a, and that's why I put it right. That's why I put it right here beside. A cannot equal 0.
Okay.
All right. B has to be greater than 0, and B cannot equal 1. Again, don't worry so much about all the different like symbols and stuff that are here, because we're gonna use this function a couple different ways today.
They remind me of hieroglyphics.
What is that? Anyway.
So guys, here's just a couple different examples of an exponential function. Here's one, y equals 3 times 2 to the x. Here's another one, y equals 4 times a half to the x. Just a couple different examples of what it looks like. All right? Now, in terms of using this function, how we're going to look at it, there'll be 3 different ways we're going to use it today. All right? One way is, okay, we're going to give you a table. Like x values on the top, y values on the bottom. And we're going to say, from that table, write a rule. All right? Or write a function.
I don't see where this is.
Yeah, this isn't on it, guys. I'm just telling you what we're doing today. All right? Second thing, we'll give you a function. You have to graph it.
We've done the giant y equals.
Third thing is we'll give you a graph.
Never heard.
And we'll say, okay, compare this graph to this graph based on what's written there. All right, so that's the three ways we're going to use that function today. All right?
Compare.
Even though I hate graphing, it makes me.
So, exponential functions are nonlinear. What do you think that means if it's nonlinear?
It can't be graph.
What do you mean non-aligned?
So it's not like that, or it's not like that.
It can't be
Say it.
horizontal.
Not straight.
Like Madison just said, it's not going to be, nonlinear means not a straight line. So when we graph our exponentials, the lines that we draw won't be straight. We're not doing y equals mx plus b. All right? So, like we talked about, right? Here's a linear. Again, this isn't on your notes, don't worry about it. I just want to show you so you guys can see the difference. All right, linear, y equals mx plus b, right? Here it is. That's a linear function.
Yeah.
That, if I graph that, that'll give me a straight line. So if you look at it, look at the x values. They're increasing by 1 every time. Right?
Wait, is this?
They're increasing by 1 every time.
Is this one on
The
the?
y, it's not on the notes, don't worry about it right now. All right?
But it actually is on.
Freddie, you okay back there?
You're always talking your mouth.
You don't, believe me, buddy, you don't need any help. All right? The y values, you're adding 3 every time. So when we're talking about a linear function. The values, the y values are going to be added each time. They're going to be added by the same number, but the biggest thing is you're using addition. They're increasing every time. You're adding. All right? So like it says here, as x increases by 1, if you add a number to get to the next y value, this is a linear function. So linear means you're adding. When we do exponentials, we won't be adding. All right? Here's an exponential function. All right? We've got the y, we get the x as the exponent. So this is exponential. The x's look pretty similar, right, Fred? What's happened to the x's each time? What's happening to them? It says, please pay attention, don't look at Xander, you don't need his help.
What is this?
It says right there, what's happening to each x value each time?
It's trend adding.
Adding by how much? 1. So what we did before, guys, with the linear, the x's were increasing by 1. Linear exponential, as far as the x's go, they're going to increase by 1.
Will it always just be 1?
Yes. When we did our linear, right? What was the one we did before this, right? Not this one, but the one we did before this, the one I showed you. What was happening to the y values?
They were decreasing.
They weren't decreasing.
Oh, they're still doing the same thing.
Were we adding? Were we subtracting?
Adding.
We were adding, right? We were adding by 3, right? We added by 3 each time. Let's see what happens this time.
What is that?
So I'm going from 2/9 to 2/3. And again, these are fractions. You're kind of like, well, I can't really see it. But look when you start getting into the whole numbers. You're going from 2 to 6, from 6 to 18. What's happening? What math operation are you using?
You're
Subtracting.
adding.
Adding.
Addition.
Am I adding by the same number?
No.
No, because from 2 to 6, I'd be adding 4. Then from 6 to 18, I'd be adding 12.
By 3.
Why can't you just multiply?
Oh, so it's going like 3.
What am I doing by 3? Say it.
By 3.
What am I doing by 3? What operation? Multiplying. That's the difference between a linear and an exponential. Linear, the y values you're adding each time. All right?
Oh.
For exponential, you're multiplying each time. Right? And when we graph these guys, you'll see what happens. So as the x increases by 1, if the y values are multiplied by a constant, This is an exponential function. So basically what that means is, guys, as the y values go up by 1, and again, just because you multiplied by 3 down here, doesn't mean you're going to be adding by 3 up here. The x's are always going to be increasing by 1 for an exponential. And then the y's should, if it is an exponential function, you should be multiplying by the same number each time. In this case, for this example we just did, we're multiplying by 3. You may multiply by 4. You may multiply by 2. You may multiply by 5. Well, it all depends on what kind of chart we give you. Now, what if this, let's say, what if that was 14 at the end?
B plus.
So I'm multiplying by 3. 6 times 3 is 18. Would that be an exponential? No, because we're not multiplying by the same thing each time. It doesn't work. Alright? So that's an example of what an exponential looks like. Alright? The y's are going to increase by 1. Excuse me, the x's are going to increase by 1. The y's, you're going to multiply by something. If you don't multiply by the same number every time, it's not an exponential. You can't multiply by 2 and then multiply by 4. It doesn't work like that. Alright? There we go. Alright, so now we want to create, that's like we talked about, the first thing we want to do. How to create an exponential function from a table. Alright? So this is where you're going to get your a and b. Alright? There's our function. Y equals a times b to the x. When we just like we did, just like if we looked at a graph and said write equation and slope intercept of the line. Right? Y equals mx plus b. Y stayed as y, x stayed as x. Same thing here. Y is going to stay as y, x is going to stay as x. The only thing you're going to be plugging in numbers for are the a and the b. All right?
Yeah.
So you must find a and b, like Mr. Hager just put. So our a, how are we going to figure out what a is? All right, let's look at it. So again, we're looking at a chart now. The chart will have an x, it'll have a y, it'll look like this, right? And there'll be numbers there. Like Mr. Hager just showed you an example. All right, so we have an x, we have a y, all right? So what the number we're going to plug in for a is the y value of the function. So I'm looking to figure out what a is. I'll look at my y, and I'll look at my x, and I'm going to scroll over till I see 0. I see my 0 for my x value, I'm going to go down. Whatever number is below 0, whatever y equals when x is 0, that's what I'm going to put for a.
Really?
So again, let me say it again. Joe, please pay attention.
Sorry.
I'm sorry too. We'll look at x, all right? Scroll over till I see x. I'll go down, whatever number is in that y spot, below x. What y equals when x is 0, that will be my a. It's that simple. No more work than that. All right? All I'm doing is looking at a chart. No math involved. All right?
I like that.
Should be.
So confused.
B. What are we going to write in the B spot? Okay. What we're going to write in the B spot is what we multiply the y values by each time. All right? So what you multiply each y value by as x increases. So like in the last one we did, it was 3. All right? The last one we did, B would have been 3 because we were multiplying by 3 each time. So figure out A, like I said, look at the 0 for x, look down, whatever number's in that spot, that's going to be your A. Figure out what B is, look at what the y values are multiplied by each time. Josiah?
Can we do it? Because
Yeah, we're going to do it right now. Yes.
How do you write that though?
What?
Like y equals 2?
So you have that big y equals on the notes, right, guys? We're going to use that. We're going to use that to start writing our function. All right.
No.
So here we're going to write a rule for the function. What should my rule start with?
Why?
Y. One more thing, Savannah.
Equal.
Y equals. Just like we were doing slope intercept. Y equals.
And then
In our function. Sydney, in our function, what's the next thing? So we have y equals, what's the next thing?
A.
A. We just talked about how do we figure out what A is?
I don't know.
It says the y value of the function when x equals 0. So look at x on the chart, and then whatever number's below it is your A. So let's find 0. Yeah, there's 0, I go down, my y value is 8. So I'll put 8.
Oh.
Yeah, I'm looking at the chart that's on your notes. This is on your notes. Again, it's what? Y equals when x is 0. Look at the x value. Whatever number's below it, that's going to be your A. It'll be different every time. Alright? It's not always going to be 8. It could be 5. It could be 10. It could be 23.
Can it be a negative?
No, it won't be negative. Alright? So, Mr. David, do you want to use parentheses or a little dot? What would you prefer? Either way. Either way.
That's ruined the
Alright guys, I'm going to put a dot just to show multiplication. If you put parentheses, you're not wrong either, but you have to put something. You can't just put the two numbers together. You could do it, I wouldn't use an X, because you might get it confused with the X that's in the formula, because you have to put the X at the end. Alright, so now, we got A, right? Remember our formula is Y equals A, what's the next thing? B. What's B?
B is
what you multiply.
Okay, tell me how you got that, Samantha.
B is.
I looked at the Y column.
Okay.
And
And what math operation is happening?
addition.
No.
Plus multiplication.
There you go. Alright? Again, so what Savannah's saying is the y values are being multiplied by 2 times 2 times 2 times 2
Y2.
times 2. That's just the way this one was. You might get 3, you might get 5, you might get 7. I don't know. Depends. But for the sake of this
That's
one,
hard to multiply.
for the sake of this one, it's 2. One more thing and we're done.
Oh, X.
Yeah. Big X or small as an exponent, right? That's it. We just wrote a rule. That's all we have to do. No more, no less. I'll have to simplify this. This is all I have to do. That's my final answer. No more than that. Well,
That's it. So where did you get the 2 from? Right next to the Y on the graph?
okay. So like we talked about, do you understand I get A?
Yeah.
How do I get A? Tell me what.
You have to do A cannot be 0, and you have to start in the middle.
Remember, to get A, find 0 on the X for the X row. Look down. Whatever number's below that in the Y, that's your A.
Okay.
Because it's what the Y value is when X is 0.
How about B?
B is what the Y values are multiplied by each time.
Oh. Yeah.
Make sense?
Yeah.
Everybody with me?
Yeah.
Yes? No? Okay.
So we're gonna have to do
Hey guys, you guys want to use the graphing calculator. Mr. Hager is showing you if you wanted to, that's what it would look like on a graphing calculator. Remember we said, it's nonlinear, which means, like Sophia told us, not a straight line. It's not a straight line, but look how quick it goes up. That's exponential growth. It starts off, right, very, very little growth, and all of a sudden, boom, it goes up really, really fast. All right, and we said what the y value is when x equals 0. It's kind of like y-intercept. Look where it crosses. It crosses the 8. That's what the y value was when x was 0. So it's kind of like the y-intercept. Like we did y equals mx plus b. B was the y-intercept. In this case, for doing something like this, the A is kind of where it crosses on the graph. Yes? All right, let's take a look at another one.
So it's pretty easy.
So again, I'm gonna write. Someone tell me what's the function we want to use?
Y equals
A times B.
Good. What?
A times B to the little x thing.
Y equals A times B to the x. Take 30 seconds and see if you can.
By myself this time.
Take 30 seconds, see if you can figure it out. As I'm walking around, this is what I saw.
Will, what was that? I'm so
That's what I saw. I saw y equals 27 times 3 to the x.
Right?
That's correct.
Okay.
Remember, someone tell me by raising their hand. Actually, I'm asking Mr. Fairbanks. Mr. Fairbanks, I know you just wrote it down. How do you figure out what A is?
By the y value of 6 as when x equals 0.
All right. So what should I look at on my chart? What number should I be looking at?
This is CP2.
I don't know.
What number should I look at?
X.
I should look at X. That's a letter, right? What number should I look at in the X column?
0.
0, right? Then where should I look? Should I go up? Should I go down? Left, right?
Left.
Go down, right? Whatever number, because again, you can't be distracted. You're not helping yourself because you're just kind of sitting there like, doesn't help. You at least give me a little bit of effort. All right. So again, look at 0. Whatever number is below 0, that's going to be your A. Look at 0. Whatever the y value is below 0, that's going to be your A. It's that simple.
Now can
All right,
I say
and then-
B?
You can say B, yes, Priscilla.
Okay, so the B is whatever you multiply from the first number to get to the second one.
Yep. So whatever
And
that.
then the rest of them.
Yeah, and guys, sometimes on a test, you may get like a fraction here, then start getting whole numbers. Don't worry about the fractions, all right? Look at the whole numbers that you know. Don't get all freaked out if you have like 2 fractions here. Don't worry about that, all right? Look at the whole, you'll at least get 3 whole numbers you can look at to figure it out, all right? Look at those 3 to help you to figure it out. All right, so again, that's what your rules should have been. Remember, A is what y equals when x is 0. B is what the y value is being multiplied by each time. That's all it is. All right, tomorrow, we might do something, maybe the numbers might go from a bigger number to a smaller number. That's okay. The rule stays the same. Even if we're going from bigger numbers to smaller numbers, the rule's not going to change.
Is it gonna be negative then?
You may get some, no.
So
Yes, you will get negative, I'm sorry, yes. So I'm saying, even if you go from a bigger to a smaller, don't get freaked out. The rules are still the same. A is still what y equals when x is 0. B is still what you multiply
So
by.
this is just the whole lesson. Only.
Yes.
Are you serious?
Basically,
I'm gonna add
basically a little
like
bit.
crazy
I don't think
stuff.
I'm gonna take
Alright, so now, next, we're gonna give you guys the exponential function.
It's okay.
You have to graph it. Alright? We're gonna give you an exponential function, you have to graph it. Alright? So, first thing we have to do, you're gonna have to set, you guys, you don't have to write this down, but I want you to write this for sure. But on the test on Friday, you're gonna have to set up a little chart, alright? On that chart, you'll have an x column. Then you'll get, the middle here will be the function. You don't have to write this, I'm just gonna show you kind of what it looks like.
Is the 1 through 4 the one that's on our back?
Yes, it should be on the back, yes, yeah. Alright, so, on the chart here, you're gonna create, guys, for the x row, all you're gonna do is, the numbers that you get for x, when we're graphing exponentials, it's always going to be -2, -1, 0, 1, 2. They're always going to be the same every time. All right? So -2, -1, 0, 1, 2. You don't have to write this. I'm just showing you. So when we ask you to figure out what the x values are going to be, don't be like, I'm not sure, I don't really know. It's always going to be -2, -1, 0, 1, 2. You do not have to make up those numbers. There's no solving you have to do. That's just the way it is. We want you to use those numbers because they're nice and small. And you get a nice mix. You got some negatives, you got some positives, the numbers are small, they're easy to work with. That's why we picked those.
Notice how Mr. Roy did his table up and down, and the table on the left is the left and right. It's
It's the
okay.
same place.
You can do the same.
Yeah, either if you feel more, I don't care how you set up your chart, doesn't matter to me. Alright? I don't care if you don't want to draw lines, that's fine too, whatever you do, I don't care. Alright? Now, solve for y. That means, because I might have a function like 3 to the x. I'm going to take my x values, I'm going to plug them in as the exponent, and I'll solve. I'm going to take my x values. Again, the x, when we're doing these exponentials, the x will always be an exponent. Always. All right? So I'm going to take each one and plug it in for x and solve. All right? And again, like it says, remember your negative exponent rule. Remember, you have to flip, right? You're going to take the base, move it to the opposite location, make the exponent positive. Third thing, once you plug in x and get those answers, those are going to be your y's. Right? That'll be your y column. I should say, it says fill in your xy column. So the x, you already have. -1, -2, 0, 1, 2. Each of those is an x value. Your y value that you need to finish the coordinate will be whatever you get after you plug in x as the exponent. It'll make more sense as we go through it. All right? And the last thing, graph the points. You'll have 5 coordinates now because we have 5 x values. -2, -1, 0, 1, 2. You have those values. All right? We're going to graph it. Remember, it's nonlinear, which means the line's not straight. It should curve up. And it should curve up to the right. It'll start on the left, and then it'll go up to the right. All right, so let's look at it. And guys, on your notes, you don't have this nice chart. That's okay. The reason why I did that is on the test on Friday, all right, you won't have a nice chart. So I want you to be able to do it without being able to set up your own chart. All right. So someone tell me, what are my x values going to be? I think I said like 5 times now.
-2, -1, 0, 1, and 2.
Yep, so -1. And guys, for your chart, you don't have to get this fancy. All right? You don't have to get this fancy. You don't have to do that. -1, 0, 1, 2. There it is. All right?
It always has to be.
Now, what do I do with those x values?
You plug
Well,
it in.
You have to plug it into x.
Yeah, and what is x? What do we call that? It's a small little thing like that.
Exponent.
Exponent, right? So, guys, what I'm going to do is, I'm just going to take it, and I'm just going to write them all in. So all I did, guys, was I just took them, and I didn't solve yet. I just took and plugged in each x value. And guys, sometimes it may be as simple as we might just give you y equals 2 to the x. We may just give you that. You may not have to do any multiplication on the outside. You may just say, okay, take this number and apply the exponents. That's all you have to do. All right, so Mr. Hager took it, and he did it on his calculator. That's fine. So I see here I have a negative exponent. That's a problem, right?
Yes.
Yes.
Can't have a negative exponent, right?
No.
What do I do? I talked about it in the warm-up.
You flip it.
It's flipper, right? Like I said,
Over 1.
like yeah. This, if we figure like this is over 1, right? It's -2 over 1.
And then you put the x
It'll become 1 times what?
2. No, it would be 1 times. 1 times. I don't know anymore.
1 over
Why didn't you just put
2
x coming up the bottom and change
to the second. That's what I just did. All right. So again, like people have been telling me, when I have the negative exponent, put the whole thing over 1, which I did. What happens is it gets flipped. The 1 comes to the top. The base, which was 2, that doesn't change. Doesn't become negative. Don't change anything. That stays exactly the same. The only thing that changes is the exponent. The exponent becomes positive. When I move its location, that makes the exponent become positive. All right? Now, 2 to the second power, what is that? 4. No, just be 4. So this will be 1 times 1/4. What's 1 times 1/4? 1/4. So my y value would be 1/4. My x value is already there. What is it? My x value is already written there. What is it?
-2.
-2. All right?
So basically X.
So there's my coordinate. Again, that's really the only like exponent stuff you're going to need to know. Each time you're going to deal with a couple of negative exponents. -2, -1. You're always going to deal with that. All right? Here, my x value, my second one, what's my x value going to be?
-1.
-1, it's already written there. Same thing. I see a negative exponent, so what do?
You put it over,
Put the whole thing over 1, then what happens?
then you bring down the -1.
So it'd be 2.
1 times, flip it, right? The 1 goes to the top, what's going to be on the bottom? 2 to the...
-1.
No, it'd be positive now because you brought it down.
Remember, no, when I flip it, no, that's the whole reason why I'm doing it, because I want to make that exponent positive. The whole reason why I'm flipping it is I want to make that exponent positive. So make sure when you flip it, the base doesn't change. In this case, the base is 2, and then the exponent is 1. What's 2 to the first power?
2.
2. We can write any number we want. Any number we write, I could write, 1,205. That's to the first power. I just don't write it every time. Just like we always know that the number to the left of a negative, the sign to the left of the number is always negative. That's just the way it is. I can write, every number we write is to the first power. We just don't write the little exponent of 1. We don't need to do that. All right? So it'll be 1 times 1/2, or would be 1/2. All right? This says, now this is also talked about last week, a couple academic weeks ago. Well, a couple weeks ago, I should say. What's any number to the 0 power? 1. 1. I don't care how big the number is. I don't care how small the number is. Any number to the 0 power is 1. So if I was going to simplify this, it would be 1 times 1, which is 1. I'm getting the 0 from right here. How did I get that 1? 1 times 2 to the 0 power. We just said anything to the 0 power is 1. 1 is part of the problem. 1 times 1 is 1. All right? Let's look at this. Now I got 1. Again, my x is 1. How about 2 to the first power? 2. We write every number to the first power. We just don't write the little 1 every time. One more. I got an x value of 2. Someone tell me for this one, what's my y value going to be? Decide? Yeah. 2 times 2 is 4. Now, if that was 2 to the third power, don't say 6. It's 2 times 2 times 2. All right? You luck out here because you can do it as 2 times 2, but this will be 4. Now, if you don't feel comfortable, all right, in this top part when you have your negative exponents, if you don't feel comfortable with that, here's another option for you guys. Do your positive exponents first. Right? Do your positive exponents first. And just know, whatever this is, so when you plug in an exponent of 1, and you have the -1, whatever answer you get down here, just put the slash and put a 1. So that would be 1/2. Same thing here. I'm going to put a slash and I'm going to put 1. So if you're not sure how to do the negative exponents, all right, you can work backwards. Do the positive exponents first, but just know whatever you get for an answer for your y, you're going to put a 1 on the top. Whatever you get for an answer for a y, you're going to put 1 on the top. But if you feel, and again, you can also do this, guys, the negative exponents. I'm sure Mr. Hager showed you last week on your calculator too. All right, we can talk about that as the week goes on. So now we're just going to graph it. All right. So here I'm going to start at -2. I'm going to be up 1/4. So I'm going to just barely be off the line. I'm just barely gonna be off. I'm barely off of that x-axis.
But my x isn't in
Huh?
the middle.
So, for us, that'd be the far left.
Yeah, that would be, so look on your graph, it kind of looks like a scatter plot. That would be, you'd be 2 lines over to the left. So you were across this here, you'd be 2 lines over to the left. All right? Now we're going to -1. Let me say, you want a graph? You can. I'll be at -1, and I'll be up a half. How would that look?
Go over -1.
Yeah. Yeah. So I'm going to be for my y-axis. I'll be between 1 and 0. Put my dot right in between. All right. How about 0? 0, 1. Like Mr. Hager's doing right now. 0 is here. I'm going to go up 1.
Okay.
My next coordinate I have to graph is what? 1, 2. I'm going to go. Now I'm on the positive side. +1 up 2. And then, what's my last one I gotta graph?
2, 4.
2, 4, over 2, up 4. Now, how do I know, based on how that looks, how do I know I did my graph correctly?
Because it's straight.
That's a straight line?
No,
It's a curve, right?
It doesn't go below the y.
And again, guys, exactly, it doesn't go below the x-axis. I know what you meant, X. And again, look at it. It starts off starts off with a little bit of growth and goes up really, really, really fast. That's how you know you did it right. That's exponential growth, right? It's going up to the right, right? So that's the second way we can do it. One way we've done it so far is look at the chart, right? Second way we've done it is using a graph. Here's the last way. So now we'll give you a function. You might say, okay, compare the function of, like right here. Compare the function. So here's the 2 we're giving you. Here's the one we're giving you. Here's what we want you to look. Here's what we want you to look at. Now, we're not saying that you have to. When we do this, guys, you don't have to graph. We're not asking you to graph every single one of the functions. You don't have to do that. We're going to show you a trick on how to do it. Right? So we're not asking you to graph these every time. The reason why we're doing this, guys, is just to give you a visual of what it looks like. All right? So here's the function we're giving you. Y equals 2 to the x. All right? We'll scroll down a little bit. Now, blue is the original. All right? Blue is the original. Red is the new. Look at it. You guys should have it on your notes too, don't you? You know, that's okay. So guys, look up here on the board. Blue's the original.
Yes.
Y is the new.
Yeah.
What's happening from the blue to the red?
It's going to the left.
It's going to the left more. All right.
Why is that?
Does it kind of look? Does it kind of look like if I took the blue? It kind of looks like I'm stretching it apart, right? From the blue to the red, I'm kind of pulling it apart. All right, so it's getting stretched out a little bit. All right. Let's see. Anything else you wanted to say about that? Okay. Again, we just want to show you that when it's like this gets stretched out a little bit. All right. Now for this one, again, blue's the original. The black is the new. What's happening? So blue's the original, black is the new. What's happening? It's going down, right? Does it kind of look like a mirror, almost a mirror image, right? But not quite. But it's getting flipped, right? Guys, what axis is this? X or Y? That's the x-axis. So what's happening from the blue to the black? What's happening to your line? It's getting
Negative.
flipped. Over what axis? X, right? So see how this number is negative? When it's negative, it's going to cause it to flip. It'll flip over the x-axis. All right? When it's just a regular whole number, it's just going to get stretched apart. It might get stretched more to the left. It might get stretched more to the right. So when it's a regular whole number, all right, not a negative, it's getting stretched apart. When it's a negative, it's going to get flipped over the x-axis. All right? Remember, we're comparing these two to this. My God, this guy. Alright. So was it 3 to the x, Mr. Hager? Or was it? Oh, 2, I'm sorry. So, again, notice how 2 to the x is here, and 2 to the x is here. The number that comes before it, or the number that's in the a spot, is what causes the change. So when it's just a regular old whole number, it's getting stretched apart. Alright? When it's a negative, it's going to get flipped over the x-axis. Alright?
Why don't we have
It's not super important. Alright? So, we're going to give you the function. Alright? When we give you the function, whatever number is in the b spot will be the same. We might say compare, like we did for the last one, right? 2 to the x was the same in all 3 functions. We said compare 2 to the x with, what was it, 3 times 2 to the x, and negative 3 times 2 to the x. So the number with the little x attached is always going to be the same. Whatever comes before it is going to cause the change. So, what does this say? What's that say? If a is greater than 1. Alright, so if a is greater than 1. So whatever number is attached to the number that has a little x. Alright? So if it was like, say it was like, something like that, right? Because this is a, this is b, right? Because it's y equals a times b to the x. So if a is greater than 1, like it is here, all right? A is, and it could be it could be a decimal too. It could be like 1.5. 1.5 is greater than 1. 1.1 is greater than 1. All right? So if a is greater than 1, like we showed you guys, that's what we showed you guys those pictures before. All right? Joe, you okay? All right, let's make sure. That means we're going to stretch the graph out. All right? So if we ask you to compare it, all right, we'll say compare the graph of y equals 2 to the x to y equals 3 times 2 to the x. The way you're going to write the comparison is like this. All right? So it's going to be written like this. You would write your answer. This would be your answer. All right? Vertical stretch by a factor of whatever number is in that a spot. Whatever number is written, or whatever number is written to the left of the number that has the little x with it. So like in this case, right, and Mr. Hager's doing it. My answer, if I was comparing that, right, it'd be a vertical stretch by a factor of what? What number is in the a spot? 2, right? Vertical stretch by a factor of 2. That's your answer. That's how you're comparing it. It's getting pulled apart, right? This would be the original graph we'd give you. Y equals 3 to the x. If I was comparing y equals 3 to the x to that, it would be getting pulled apart, like we showed you guys with the pictures. It'd be getting pulled apart. All right? So if you understand if you understand the function y equals a times b to the x, that's great. If you don't, basically, it's going to be a vertical stretch by whatever number doesn't have the little x attached. All right? So a vertical stretch by a factor of, in this case, it would be 2. Now, we also looked at one where that first number after y was negative. All right? So if a is negative, think about this now. We showed you that graph before, right? When the first number was negative. What happened to the graph?
Can you say that again?
We looked at those graphs before, right? Remember the one that had the black? What happened to it?
It was only like up and down.
It got flipped, right? So when it's negative, like Madison just said, it causes it to reflect or flip. If you say reflect, if you say flip, either one works. We'll take flip, right, Mr. Hager? Yeah. If you said the graph is flipped over the x-axis, that's fine too. Fred, you're writing this down, right?
Yes.
Okay. You play baseball, right? No. Just making sure. So this causes the graph to reflect over the x-axis. So when the first number written there is negative, all right, it's going to cause your graph to flip. All right? So I write it like this. This one's a little bit longer because it's negative. because the first number is negative. All right? So it'll be a vertical stretch by a factor of whatever A is, whatever the first number written is. Make sure when you write it, though, don't write it as negative. You want to keep it positive. All right? So it'll be a vertical stretch by a factor of whatever A is. Make sure you keep it positive. And reflected or flipped over the x-axis. So say if we gave you this, let's take this for an example up there. Y equals negative 2 times 3 to the x. How would I write my answer? How would I write my answer? You have it on your notes. Like, guys, basically, we're like, all you're doing is just like a fill in the blanks. Like, we're giving you the sentence, you just have to write in the numbers. In this function, right? What number is in the A spot? Or what number comes first?
-2.
Okay, so vertical stretch by a factor of
-2. Bigger than -2.
2, right? So vertical stretch by a factor of 2. And this is a 2, because it's negative, this one has 2 parts. Because it's negative, what's happening?
It flips.
Good. So, and flipped over what axis?
The X. Yeah.
Flipped over the x-axis.
You want us to write the vertical stretch by factor?
I would.
A stretch of 2.
So you got, guys, on your note, oh, that's not on it. We're not on. We're going to give you guys, again, we're just showing you guys examples here. Just how to do it. We're actually going to do example 4A and 4B in a second. All right? So again, when it's negative, all right? Whatever number doesn't have a little x with it, that's the number you're going to put in your answer. In this case, it's 2. Vertical stretch by a factor of 2, and because it's negative, it's flipped. All right? Everybody good with this?
People see what the negative is doing and what the 2 is doing?
Our banks are fine.
Like Mr. Hager did, like, whatever number the number it's stretched by, you're always going to write it as positive in your answer. Then, if it's negative, that's what's causing it to flip. All right? All right. So this, right? Again, here's your original graph. Y equals 2 to the x. Here's the new graph.
Where's their final?
Huh? It should say 4A. It should say 4A. All right? So here's your original. Here's what we're asking you to compare it with. So on your notes it says compare the graph of, then it's a blank. You want to write that. With the graph of blank, you want to write that. So, what should our sentence start with?
I thought this wasn't going to be
guys, on your notes, we wrote on the notes, written like. That's basically the answer. Look at your notes. Look where it says written like.
vertical stretch.
Vertical. I don't care if it's negative. I don't care if it's positive. I don't care if it's a fraction. When we ask you to compare graphs, your answer is always going to start like this: vertical stretch. What's the rest of my sentence going to be?
By a factor of.
Yep, good.
Oh.
Whatever.
2. No, that's 4.
4. See how these two things match, right? 2 to the x, 2 to the x. See how they match? Whatever thing is whatever the thing is there that's different, that's what it's getting stretched by, right? The 2x and the 2x are the same, right? But this one has a 4. That's what it's getting stretched by. Does that make sense now?
Yes.
Yeah.
So whatever the different number is there, that's what it's getting stretched by. All right? These are always going to match. That's going to be different. All right? And then, now, for that last one we just did, would that be a flip?
No.
No. How come?
It's not negative.
It's not negative. Good.
Yeah.
Here's our negative. Z. What's my sentence going to start with?
Vertical.
Good, the vertical stretch. What are the next three words? Vertical stretch. What are the next three words?
By a factor.
By a factor.
-3.
Careful.
Oh,
That's
three,
it,
positive
3. When we're comparing it, right, when we're saying what the factor is, we always want to keep it positive. By a factor of 3. Am I done? Why?
Yes.
Because it's negative. So what do I have to say?
And flipped
And flipped or reflected?
over the x-axis.
Nice job. Alright, so it'll be flipped over the x-axis.
I won't.
Again, what, see? 4x, 4x, they match. The -3 is different. That's what you want to write.
I like to start with vinegar in my stomach.
Next, homework, guys. Homework's really short tonight. I think there's like maybe 7 questions. Alright? Guys, listen. Guys, I know you're packing up your left time, though. Test on Friday. It is your last one of the quarter. Remember, no class on Wednesday.
Or Thursday.
No class Wednesday, and we only have 1 period. Guys, only a single period class on Thursday. If you're not trying to do this stuff, I'll be after school on Thursday if people need to stay.
I'm staying with Miss Marini.
Guys, your last day of new, guys, stop packing up and listen. Your last day of new material will be next academic Monday. We're gonna do a few more things with this. That'll be the last day of new stuff. The rest of your next academic week will be all review for the final. All right, and then final exam will be Monday, June 18th. So that's like, understand, guys. We have an academic week. All right. Then we have a full, your last shop week. Then when you come back that day, the last week of school, that Monday is your final. So you have a whole week off of shop before the final. Mr. Hager and I'll be after school if you need it.